Hi there, welcome back. Welcome back to the channel. Another Grundig. Yep, you saw it. Somebody else saw it in my previous video and they actually mentioned it. I think they sort of saw the back end of it in the back of the workshop and they guessed that this was probably coming up. And yeah, here it is. This is the Grundig Satellit 3400. I've been looking for one for quite some time. I found one and just to make it better, it doesn't work. According to the seller, it doesn't work at all. I got this one from a seller in France. These are quite sought after. You can get quite a few, but the prices are going up. Especially one in working order. Prices are going up quite steadily. In fact, that's a point that I wanted to raise. The prices of some of these receivers, especially the two-bearer ones, have gone up dramatically in the last few years. I've noticed as I've been buying them that the actual market value they're fetching is going up dramatically. In fact, if you were a sort of investor, I suppose this could be considered a future-proof commodity. Not so much for its use, but for its intrinsic value. Anyway, this one is the 3400. It actually is quite a step up from the last one I did, which I considered the best receiver I'd ever done, which was the Grundig Satellit 2100. I did a series on that. I'll link to that above or below. I'll link to that. And I really enjoyed restoring that radio. It has some very interesting features. It's very well documented in terms of service manuals and schematics and instructions and everything else. And this one too has that feature. In fact, I found a lot of stuff on the net and it wasn't the best resolution. So I contacted a friend of mine, and he's a viewer of the channel who's helped me quite a bit with information in the past. He actually sent me a full package of information in high resolution scans and everything else, which is going to come in really useful. Because this thing doesn't work, as I mentioned, and if it doesn't work, it just makes it more interesting to work on. But before going on, I'll be going through this. I hope to create a full series on the cleaning. There's not that much to do. Repairs, there's a couple of switches that are gone. The alignment, the recapping, probably the audio section, and if not just the audio section, we'll see what else we need to do. But I do want to do a full series. I want to do this in good time. I really enjoy these radios. I enjoy working on them. So I'm not going to rush this. This isn't for a client. It's never for a client. It's usually for me or for a friend of mine. And I'm looking forward to seeing how this thing compares to the 2100. Maybe the 2100 will have to find a new home. These things are big, so two of them in a small workshop, I don't know if they'll get on too well. We shall see. Let me show you some close-up details on this. Cosmetically, this thing's looking generally very good. There's a little bit of dust here and there, some of it on the grill of the speakers. But generally, it's in pretty good shape. There are two notable exceptions, and those two are pretty glaring. These two switches are gone, and it looks like, oh, this one's still operating. Okay, that's still operating. So narrow band spread, medium band spread, and wide band spread. That'll give you less selectivity, but better fidelity, okay? And this one here is the selector for the band or the band spread. So if you've got it on, say you've got it on shortwave 9, then you can put it on the full band of shortwave 9, or I think this one's completely gone. Or you can put it down to the band spread, and it gives you the, what would it be? 15 meter band or 30 meter band. So it basically gives you a more concentrated tuning ability on the commercial bands within that particular band over there. So those two are completely gone. Then over here we've got the earphone socket. We've got our volume control, our treble and our highs. So this apparently it's got very good sound quality, so I'm looking forward to hearing this on FM. And then over here we've got the power on-off switch. We have the, this is the dial lamp. So you push down, it lights up the dials. You remove it, the dials go off. That's to save battery. This thing has got a tweeter activator. So if you put it on top there, you only get the main speaker. If you push down, you get the main speaker and the tweeter. This is used for example, on FM, where you know you've got good fidelity, so you improve your sound. It's more or less what you'd probably call the speech and the music selectors on some of the older radios. This is the counter switch, and I don't know what it does. Unless there's a counter function in there, I'm not sure. There we have the BFO, or activating the BFO function, so you can listen to amateur bands. It's got an internal BFO. ANL, what is that? Noise reduction. Automatic noise limit or level. Then we've got automatic, click it on there, you've got automatic gain control. And if you take it off, you have a manual gain control. So you've basically got a manual RF gain over here. And this allows you to remove or reduce the gain when you're listening to, especially amateur bands. In fact, I think it'll work on all the bands, but when you're listening to amateur radio, sometimes you need to play with the gain instead of having an automatic gain. And then here we've got, if you're choosing BFO, you've got upper sideband, lower sideband. What this does is the BFO produces it's the IF frequency, which is 460 minus 1 kilohertz for the upper sideband or the lower sideband. What is it? Minus 1 kilohertz plus 1 kilohertz. So one of these is 459 kilohertz. The other one is 461 kilohertz. And then here we've got the fine tuning of the BFO. If you've seen my video on that external BFO, you'll know that by simply having a set frequency above or below the IF frequency sometimes is not enough. You can fine tune it over here, up or down. Okay. And up here we've got the AFC switch. So for FM, automatic frequency control, on or off. It just fixes your frequency once you've tuned in. And you either put it on or off. You've got the battery and the tuning indicator. So either tuning, so it'll give you a tuning indicator here, or battery level. When you click down, you'll see what your battery level is if you're using it on batteries. This thing's got the option of a fixed rechargeable battery or 6, I think they are A cells, I'm not sure. So you can run it on battery or mains. You've got an antenna tuner. If you select external antenna, you can fine tune it. This is obviously on the front end to make sure that you're coupling correctly into the radio. Then you've got the, as I mentioned, the band spread, fine, medium and wide. You've got your quartz time here. Apparently this thing is just a timer or a clock. It doesn't really allow you to program in switch on, switch off. It's really independent. In fact, you can just remove it. And there it is. It runs off a couple of button cells. I'll just take this out for now. And then we've got the different tuning for the different bands. This top one is just the VHF, just the FM band. This one here takes care of the 4 lower frequency ones, the long wave, medium wave, shortwave 1 and shortwave 2. Shortwave 2 goes to 5.2 megahertz. So that allows you to tune any one of those bands when you select it at the top, which I'll show you in a second. Then down below, you have the tuning for the other shortwave bands, which you select on this drum tuner. You choose your band, there's shortwave 10, 9, 8, and so on. You can see those connectors are pretty dirty. That's usually the cause of most of the problems with these bands. So these have to be very carefully cleaned. But you click it into place and you get your different ranges. This thing goes all the way to 31 megahertz, I believe. So you tune on here. On the side here, you got your drum selector, which I've just shown you from the front. It seems to be, none of them seem to be stuck, which is a good start. These are the main selectors for your input, whatever you want to listen to. FM over here, long wave, medium wave, shortwave 1 or 2, and then shortwave 3 to 10, which lets you then choose the specific band with the drum tune on the side. This is external input, so tape or phono. This is actually an external antenna selector. So you can choose to use the ferrite or the rod antenna over there, or you can use an external antenna. This antenna actually is in very good shape. Perfect condition. These things are difficult to get hold of and usually broken or bent or something similar. So I'm glad to know that this one's fine. And here, if you choose FM, you then have 6 presets which you tune in at the back, and so you can just select whichever ones you want. This is only for the FM, and it seems to deactivate the general FM. Okay, let's look at the back. Once again, this thing is in very good condition. No breaks, no chips, no dents, no deep scratches. And if we look here, this is basically all the controls or the inputs we've got over here. We've got the tape in and out over there. This is the, what is this, a dipole antenna for FM. This is another connector, but there's one over here. I don't know why they duplicated. Ground and antenna in. So it'll be long wire. Maybe this will be a loop. I'm not sure. We'll check the schematic later. This is for a car antenna. So you could use a car antenna in there or a boat antenna. And then this is the tuning for the 6 FM presets, as mentioned. This thing is, what is this? What is this? I don't know. Store your change or something. No, I think this is for the mains cord. And here we have the speaker out, 4 ohm speaker. And this is your mains in. This one uses one of those, this type, figure 8 sockets. And the way it works is you press this up or down. Up is for 220 to 240 volts. Down is for 110 or 120. So you click that down or up. I'm going to leave it up. It seems to be a bit stuck. I think you push it in. And then what happens is that there's a groove in there. And this allows your this little door to come out. And that lets you connect your mains socket in there, mains plug in there. It also gives you access. It opens up this socket here for the external supply, DC supply, 10 to 16 volts. It's got a funny sort of socket. I'm not sure what kind of plug would go in there. I won't be using it, so it seems to be okay, but I won't be using it. Anyway, this thing has got a fuse in here, so we'll have to see that, see how that is later. But what I'm going to do is I'm going to leave this in there now. Okay, I'm going to turn around and we're going to power it up, see what happens. Okay, let's give it a try. I've got the power on there. The mains is connected. Oh, that was so dramatic. Nothing, absolutely nothing. Is there any trick over here? Is there like a battery or mains selector or not? No light. No, absolutely dead. Just the way we like it. This is always so weird. You get all ready for it and then nothing happens. Okay, it could be the switch, it could be the fuses, it could be something else on the power supply. Obviously, first things will be the power supply. We'll check that up. Make sure that mains is getting in. Make sure that the AC is being produced by the transformer. Make sure that's getting rectified. Yep, the usual steps. I'm going to check out the schematic, open up the back. I believe it's pretty simple. There's like 4 screws on the top, 2 on the sides, 2 on the bottom, and the back comes out. I have been warned that to get to all these boards, you do have to remove this thing from the actual enclosure completely. Yeah, this thing is big, it's heavy, and you can do quite a bit of damage if you're not careful. So I'm going to try and see what I can repair at the back first before I get into that stage. Right, as advertised, it's pretty easy to remove the back. I've got the power in here just for now. I am going to, before I power it up, I'm going to check the fuses, but I just want to have a quick look at this. This will be the drum tuning inside here with the rotary selector on the side. Okay, power supply I presume is down here. I'm not sure if these are rectifiers or regulators rather, or whether it's got to do with the audio. I'm not even sure where the audio board is. Transformers obviously here. What have we got here? Probably the IF board front end, FM front end. I'm not sure what this is. This might be the IF board, IF strip detector and so on. I haven't looked at the data too well. I've got a lot of data, but I haven't looked at it too closely. All the selectors at the top, the tuning on here. This will be variac tuning, so this will just be, I presume, it'll be like little pots, which creates different voltage, which then creates a different tuning frequency. So nothing too dramatic on there. I think the IF for the IF board for the higher frequencies, the one with the, that you use the side for, that thing's got the dual conversion. So it's got a 2 megahertz IF frequency and then the 460. That might be a separate board to the lower frequencies. But all in good time. At the moment, I just want to check the power and see why this thing's not giving me anything. Yeah, you can't get far without a power supply. Let's see how this thing works. You've got your mains coming in here. It goes through a fuse. This fuse, I believe, is the one that's fitted inside that slider selector that I showed you, where you flick up for 220 volts, flick down for 110. And that slider has these switches here. Z1, Z2, Z3, Z4, Z5. So depending on how you flick it, whether you flick it one way or the other, it'll either put these two windings in parallel if it's for 110 volts or 120, or it'll put them in series for 240. So if you look at this here, you've got the winding goes in there, there, comes round, series to there, perfect. This thing is set, this design or the schematic is drawn for the setting of 220 to 240 volts. So your mains comes in here and your secondary is over here, 13.5 volts AC. It's important to identify some of the connectors, like I've just done with that switching system. This connector here is actually the black connector on the side there, and the pins are, it says here AC out is pin 3 and pin 1. So we'll be able to see it on there. It goes through a fuse which is internal already. This is fuse 2, which is on that board as well. And then it comes to the rectifier, which is actually difficult to access over there because the pins are facing downwards. I want to see what I can determine without removing anything at the moment. And then we've got 16.8 volts over here. Now where can I access this? What they've got here, these capacitors are just to reduce any noise on the rectifier. When these diodes, this is basically a bridge rectifier, it's got 4 diodes. As they switch, they can generate a bit of noise, and the 0.1 microfarad caps just filter that. Nothing too complicated here. So what you've got here, 16.8 volts DC, unfiltered at this stage, and it goes up here. Okay, and then it meets these switches. Now what are these switches? This is a 7, 8, and 9, and it goes up here, and this is XXX NB. What would this be? This would be battery, if you're using the battery. I think these switches here, this slot here is the other, it's the other set of contacts inside that that black unit over there. So you can select between using mains, which means that it just goes up to there, through there, up to here, and it goes to this switch, which is A and B. A5, 4, 5, 6, and B, 1, 2, 3, and there's A as well. But I want to see, I'm looking at this capacitor here, 4.7 millifarad, so 4,700 microfarad, and I consider this to be sort of the main filter cap for the DC. So I want to see where I can, okay, this is a good point. You see this diode over here, diode 601, the cathode of it, we can easily identify that on that board on the top. So what I'm going to do is I'm going to connect a multimeter to this point here and to ground, and I'm going to power this up and see if I get, what am I supposed to get? 16.8 volts. Okay, let's try that. There's our diode 601, and we want to connect it to this end. The ground, or the negative of the multimeter, I've just connected to the negative of the battery, which I know is a common ground. I have the radio on at the bottom, so I've activated the on-off switch. Just make sure of that. Actually, I didn't have it on, but it doesn't matter really. This voltage is before the switch, so let me switch on the supply. It usually helps if you plug it in. So I've got 220 selected up there. Push this in, plug it in, and I'll switch it on again. Oh, it's going up 16 volts. I've got no limit on there. I've got no noise coming out, but I've got 16.1 volts, which actually sounds or looks like it's correct. There is one thing that mystifies me a little bit, and that is 1.3 volts of AC, which we can check separately. This thing's got 1.3 volts of AC on there, which seems pretty high on 16 volts of DC. So it tells me that perhaps that filter capacitor, the 4.7 millifarad, 4,700 microfarad, that might not be doing its job. It might not even be connected in. So the problem could be with the switching. It could be the switch, which is on the front, and I have to dismantle this whole thing to get there. Okay, but we've got something. We've got ourselves 16 volts. 16.3 volts. And if I actually filter that a bit better, I wonder if it wouldn't go to 16.8, meaning that 1.2 volts over there would be filtered out. The reason I'm a little surprised is if you've got a supply like this and it's supplying almost nothing because the switches are not in operation, then you should almost have a fixed DC voltage without any ripple. The fact that there is some ripple means that either there's quite a bit of current being drawn, which doesn't look like it from the reading on the dim bulb tester. It's drawing 10 milliamps from mains, or the alternative is that there's almost no filter capacitor on there. Let me just try something. Just to prove my point, I'm going to connect a 470 microfarad capacitor to the 50 volt cap. I'm going to I've got the ground connected to common ground, and I'm going to just touch the positive to that test point over there. Now remember, we've got 1.16 volts ripple. Look at that. Hang on. There we go. 17.3 with 0.06 volts of ripple. Okay, that tells us quite a bit. What it tells us is that filter capacitor is not in circuit at all. Good, we know what the problem is, the switch. Instead of 16.8, we're actually measuring about 17. At that point, we're actually measuring at this point by the diode. And what I did is I connected 470 microfarads from there to ground, and the ripple fully disappeared. Because at this point, if you look at it this way, the way the switch is in the on position, which I think it's in the off position, drawn in the off position here, we would have the supply would go here, up here, through there, through there, through there. And if you put this on, this is made, that one there is broken. You'll see why that is there in a second. And then the supply would come down here to there, and it would meet this 4,700 microfarad capacitor, and it would be filtered there. So it's not getting through the switch for some strange reason. Not strange, the switch has probably got a problem. The reason it goes to there when you switch it off is so that the charge on this capacitor, when you switch it off, would go there, across to here, and through this resistor to ground, just to take that down to 0. So you don't leave a charged capacitor in there. It would also make sure, this is 18 ohms, so it's fairly small. So this discharges pretty quickly through there. And it just makes sure that the sound actually dies as you switch it off and doesn't play for a while, as it sometimes tends to do if you switch off and leave the capacitors charged. So we know that this thing is working to here, it's not getting to there. Which makes sense that we won't get anything if we're not getting a voltage there, we're not getting a voltage, actually we're not getting a voltage practically anywhere. We're not getting it coming into the amplifier. This is the amplifier section. The 2 transistors in push-pull over here, which then goes through a capacitor. This is not dual supply, so this point here would be at approximately half the voltage range. So you need a DC blocking capacitor to get your audio out to your speakers. And that makes sense. Okay, so what can I do? What can I do to test this further? I know there's circuits down here that have to do with, for example, this circuit here. If we look at where this goes, actually it comes out of here, it goes to here, here, here. It actually comes to the charging pin of the battery. Adjustable with R68. So you adjust the charging voltage. This thing's got the capacity to have a rechargeable battery. And this is your charge contact. So you put your battery in there and you can charge it when you've connected to mains. And of course, what happens down here is this thing creates or regulates the voltage and creates a charging circuit for the battery. So if we don't use this, we're simply not getting a charge on there. If we are using it, I'm trying to see where I can supply voltage to make this thing work. So it would go through here, through here, through here, through there. And where would... Okay, I've just seen where I'm going to use... Okay, I can see these 2 transistors on the top there. T607 and 606 and 607 rather are actually visible on that board. I'll show you in a second. And if I take supply, let's call it, well, it says here from 10 to 16. So I'm going to put 9 volts in to this point, and the place to access this point is actually there on the collector of 606. Then I believe we have supplied the radio. Obviously this part doesn't get supplied. Actually it does get supplied. This is all the lamps. Okay, through that transistor. 610, where's 610? Yeah, transistor 610 is also on the top. So on the top there, those transistors that we see are T606, 607 and 610. So I can also just look for the collector, this point here of 610, give it 9 or 10 volts and see if this thing operates. Let's try that. There we have it, connected to the collector of 610. You can see the transistor number over there. It's on the collector. I'm just going to flip this around so that I can see what I'm tuning into, if it works. And we'll switch on the power supply. This is a DC supply with current limit. I put, what did I put in there? 100 milliamps current limit, just so we don't create any shorts. Let's try that out. Okay. Switch is on. I don't think that makes any difference whatsoever. Let me activate the supply. It's drawing 150 milliamps and I can hear some noise. Got FM active. Let me reduce the current limit to 250 milliamps. Okay, I've got 12 volts. Dial lamp is on. I've got 12 volts. It's drawing 170 milliamps. The limit is set to 250. Okay, it looks like it thinks it's got a battery on there. So that's working. That is still off. Oh no. Oh, it's drawing a lot of current. And let me increase the current limit again to 350 milliamps, maybe. Brilliant! Ha! Okay, it was stripping the current limit. So I've got a readout, 89 megahertz. Oh, I can hardly hear anything. I can't hear anything. Let's try to put the antenna up. Volume's on max. There should be a strong station right here. Can hardly hear it. There's another strong station here. Can hardly hear that. The antenna's up. It's on FM. Internal antenna. Okay, but it's picking up something. Just a note, this is Canary Islands. I am picking up a local station and one from the Canary Islands on FM in the middle of the day, which tells me the reception is very, very good. There's something wrong with the audio. Very wrong. That's not working. Okay, that's to leave it on permanently. That's off, that's momentarily. Just saves you on battery if you've got battery active. That seems to be changing the static. Okay, very, very poor reception. I'm sure we won't get anything on here. What is it? Medium wave. Let's see. That's reading okay. Let's go to 1530, which is where my local station is. Absolutely nothing. Right, something's definitely wrong with a few things. Shortwave 1, shortwave 2. It's doing something funny there. Let's try 3 to 10. It's trying. Won't go beyond 7 for some reason. I don't want to force it. If I just wiggle this turret tuner, noise comes in. You see, that's got to do with those contacts over there that are very dirty. Okay, no surprise there. That should be, for some reason, that's created a short. The supply just tripped. Okay, it's because I short things out to the battery charger and everything else when I switch that off. And I'm supplying the voltage to the wrong place, as it were. All right, well, let's see. I'm pretty happy that that's working. I'm pretty happy. Something's working, which is good. So we figured out that parts of this is working. In fact, most of it is probably working. There's obviously something wrong with the audio amplifier circuit, but I'm not sure if it's that or the fact that some parts of the circuit might not be getting the right supplies. It could be that the filtering won't be a problem because my bench supply is very well filtered. So there's obviously something wrong with this, starting with the on-off switch with a power switch over here. This thing is not putting through what it should do. So I'm going to have to remove this whole thing out of the chassis, out of the cabinet or the chassis, and look inside, look at it from the front. I'll have to remove all the knobs, there are a few screws. In fact, the instructions I have do tell us how to do that. So I'll be doing that, and I'll take this one step at a time. First step will be to sort out why this thing is not powering up properly. And then I'll take it one step further, check the audio circuit. We'll be sending a signal into the external input up there. That's usually the best reference that you can have to check your audio section, your preamp, your tone boards, and your power section. If we sort that out, then we know that our audio is fine. And then we take it to the radio sections and see what needs doing, if anything. I'll be checking some of the capacitors on there. And I do want to go through the alignment procedure. I definitely have a problem here. I need a new switch there, and I need a new switch there. So, and I'm hoping that I don't need a new switch here, because this thing is a, 9? It's basically a 3-pole 2-way switch in the vertical sense. You know, it's got 3 different poles, but it's got 2 poles but 3 switches. So it's quite a complex switch to find. I'm hoping it's not damaged. Usually you can open them up and repair them. But yeah, this is my new baby. This is what I want to really dig into, and it should be fun. I hope you enjoy it. I know that a lot of you were incredibly generous with comments on the Satellite 2100 video series. So obviously there are a lot of people out there that suffer from the same disease that I do, which is never enough Grundigs or any radios for that matter. So I do hope you'll join me on this quest. If you have any suggestions, comments, whatever, please feel free to write them in below. They're always welcome. And if you like this video, please click like and share it on social media and subscribe to the channel and all that jazz. And if you want to support the channel directly, please do so on Patreon. Links are at the end of the video and in the description below. So once again, I want to thank you for watching. Bye for now and stay safe.